Hello everyone, welcome to this session on system design. Primarily objective of this round is to help you guys tell you about what kind of questions you can expect in system design round, and more importantly, how do you answer in a particular system design round. So we'll take one example, we'll discuss one framework around what should be the ideal framework around discussing such questions. All right then, let's get started. So the agenda, first, let me give you a brief about why these system design topics are important. They have importance in two areas, right? One is your ongoing job, and the other one is the interviews. So whenever specifically it makes sense for people who have higher experience, right? People who are coming from, let's say, 2-3 years of experience, they are expected to have some knowledge about system design, right? So system design encompasses two main components. One is the low level design, wherein you'll be expected to either write the schema or maybe design the APIs or maybe design the class, like what are classes and interfaces, how would you design that particular code. And the other one is having a broader perspective of how different components are going to behave. So typically to have you'll basically get around 1 hour or maybe some more time to discuss a particular system in detail during your interviews. So it's best to follow this particular framework. I have followed this particular framework for Facebook, and I was able to crack Facebook with this particular framework. And whenever you apply also, your recruiter will also tell you about the same framework that I'm going to be telling you. So without wasting more time, let me just introduce the framework to you guys, and then maybe if you have any questions, you can type it down in the comment section. I'll read the questions from there, right? So the framework has 5 steps. It's a 5-step framework. You always start with gather requirements, right? So your first step should be to gather or ask clarifying questions about the requirements. Most of the time, I'll give you side by side, whenever I'm giving you the framework, I'll also give you one example and correlate how, if for this particular question, what should be the ideal answer or ideal output. So let's suppose I'm asked to design a URL shortener, right? Let's suppose I appear for a Facebook interview, and my interviewer asks me that, hey, you need to design a URL shortener. Now, this by itself will basically give you some hints about how you should typically approach the problem. Even if the problem is 100% clear to you, you must ask some clarifying questions. Most of the time, the problem will be vague enough that you will have to ask, clarifying questions. But even if the problem is crisp, clear, just reiterate the problem in the same, in your words, so that you and the interviewer are on the same page, right? So gather requirement step will basically, for example, if I'm asked to build a URL shortener, for me, the requirements can be, do I need to add personalization, or do I need to add support for analytics? Do I need to support things like expiry of a particular long URL? If somebody uses my service and I give a particular short response, for how long should I persist that particular short URL to long URL mapping? That is also a business statement, and that will dictate how my design will look like. So it is important to ask such clarifying questions in the gather requirement phase. Now, I hope the first point is clear to everyone. Let's move to the second point, which is once you've got an idea or got a sense of the requirements that you'll be building out, just write all those requirements down on a piece of paper or Google Doc or anywhere, right? If you're doing it on a whiteboard, you write the requirements, freeze the requirements on the whiteboard. It is important to note here that do not spend lot of your time on this particular part, gather requirements part, maybe 1 or maximum 2-3 minutes on this particular aspect, right? After that, you need to spend time on estimating the scale. Now, there are multiple subsections to estimating scale. The sense or the idea that I'm trying to get out of estimate scale is, now this is also one more area, just like gather requirements, your interviewer will work with you to basically give you the requirements. You'll give certain assumptions, the interviewer will say yes or no, right? Or maybe you can ask question to the interviewer and he'll give you the answer for that. For estimate scale also, for example, if you don't know what your starting point is, just ask how many daily active users are going to be there. So for example, I was asked to design a URL shortener. I asked my interviewer how many users are going to use it, or how many daily active users are going to use it. So let's suppose my interviewer said that there will be 1 million users, which I can expect to use my service. So in the estimation scale step, what I need to do is I need to convert this 1 million daily active users to find out how much storage is going to be required to convert these 1 million daily active users. Now, my interviewer also tells me, or I tell him that, hey, I am assuming that 90% of my users will just read the data and only 10% of the users will write the data, right? Now, this is a one assumption that I'm making. I'll express this particular assumption to my interviewer, and based on whether he says it's a fair assumption or not, I'll change these numbers. But for our system, let's suppose these are the numbers. So 10% right means that 1 million into 10%, which means around 100k users are going to write something are going to generate data on a daily basis. Now, what is the data that these guys are generating? These guys will give me the big URL. I'll have to somehow do some transformational magic here and return a small URL in return. This big URL can be, let's say, 100 characters, and this short URL can be 10 characters, right? So this is the kind of transformation that I need to do. Let's suppose to store the entire record, I can store it using 1 KB of space. So what is the daily space that I'm going to need? The bare minimum daily space that I'm going to need for my system? It will be 1 KB of data for one record, because one record is taking 1 KB, multiplied it by the number of users that I'm getting who are generating the data on my website. How many such users are there? There are 100k. So this is 10 to the power 5, which is something around 10 to the power 5, 3 MB, around 100 MB of data, right? This is on a daily basis. So Bhagyarana says that it should be 1 million into 10 to the power, into 1 KB. It won't be 1 million. The reason it will not be 1 million is because only 10% of my users are generating that particular data. Not all of them are generating the data. The people who are generating the data, that means they're using my service to shorten a particular URL. Only those users will be considered. Hence, I've taken 100k users, right? Which basically means that I'll be storing around 100 MB of generating around 100 MB of data. And if I have to calculate for a particular year, then it will be 365. I'll have to multiply it by 365, which would be around 3.65 or 36.5 GB of data. Right? On a yearly basis, my service is going to be producing this. Why am I not taking the read into consideration while storage? Because I'm only storing whenever a person is requesting a shorter URL for a long URL that I've got, only then I have to store that particular URL. What happens when a person wants to read that particular URL to a big URL? If a request comes for reading this particular URL, I'll go to the storage, I'll read whatever is the corresponding big URL, and I'll return it back to the user. So in that, I don't need any storage, right? So the second step, which was estimating the scale, the most important thing is to estimate how much storage you are going to require. Because this number, this 35 or 36 GB number that I've got here, tells me that only one instance can basically hold this particular data. The entire data for 1 year can fit into one machine itself. If this would have been around 1 TB or more than 1 TB, I would have required multiple machines to store that particular data, and hence I would require more. Since I require more machines, I would require some sort of a sharding, right? But in our case, we've seen that it is just around 36 GB of data. One instance can handle it. There are still problems. We'll come to what are the problems. But I'm just giving you what are the numbers that we need to take care of, right? So coming back to are important parameters for estimating scale. First was the storage. The other important parameter is to identify the TPS of your system. That means how many requests are you getting per second. That includes of write TPS. Write TPS would be that a person is giving you a long URL and you need to return a short URL for that. A read request in this scenario would be a person is giving a short URL and you have to return a long URL. So you need to find out the TPS of every system. TPS, the full form of TPS is throughput per second. People call it QPS as well. QPS is query per second. Some people call it reads per second, writes per second, and bifurcating it. Basically, the crux is that you need to find out what would be the number of requests for reads, what would be the number of requests for writes. Because if these numbers are also very high, let's suppose you are getting 1 million reads per second, that means that you need to have some sort of a caching enabled, you need to have some replication enabled, because one server will not be able to cater to 1 million IO calls. So there is a network bandwidth limitation as well. This is the reason why you should estimate the TPS as well. I hope that makes sense. Now let's move to the third important part, which is once you have estimated the scale, then you look for what are your design goals. What should you solve for in this particular problem? Design goals, if I have to just give you an idea about what typical design goals are. If you have not heard about cap theorem, just go to our YouTube. There's a playlist on system design. Go to that playlist and see all the primer content. So there's a theorem called cap theorem, which states that either in a scenario of a partition tolerance, you can only have either consistency or availability if you're taking the partition tolerance into account. So one of the design goals is to identify whether you're designing for a very consistent heavy system, or are you okay with eventual consistency and you prefer availability on that particular scenario. So identifying that is one part. Let's talk about the case that we are building. Do we need at most consistency? If I just have to explain consistency in 2 lines, consistency states that if there are 2 data nodes, let's say there is data node 1 and data node 2. Now, if the value of x is, let's say initially x is 5 in both the cases, then I get a write request which basically updates the value of x to 15. And let's say that particular value was written in data node 1. Now, if I fire a read request, depending upon whether it is going to data node 1 or data node 2, 15 or 5 would be returned. In a strongly consistent system, we'll get 15 as the response. In a weakly or in an eventually consistent system, I may get 15 or 5 both, depending upon whatever is the output. So do I need at most, do I require my system that every node, every data node in my system should have the exact same data? The answer is no, because there are very less updates. I'm just adding whenever I generate a big URL, once it is copied, once it is added into the database, I'm not modifying it. So either the date value will not be there, or if the value is there, it will be same for all the cases. Right? So I don't need consistency. I can live with eventual consistency. Do I need availability? I don't want, if I've generated a particular URL and I've sent it to millions of people. Let's say it was a Google I/O event, or maybe Donald Trump, or maybe Modi ji giving some speech, and to that link to that particular speech, I have let's say shortened it using my service and I've sent it to multiple places. If those people are not able to reliably see the output or reliably able to access my service, in that case it will be a massive hit on my website and the credibility of my website. Hence I cannot let go of the availability part, right? So design goals mein, you need to identify this, that whether you need consistency or should you prefer availability. In case of a partition tolerance we've seen, we most of the cases, you would require some sort of a partition, right? So that was my third part, having the design goals. You first identify what trade-off you will have, consistency versus availability trade-off. And the second trade-off is between latency, right? What is the kind of latency are you looking at? So let me just write it down and then I'll explain what latency means. Now, different systems would have different requirements for having different requirements for latency. For example, the URL shortener one that I've given you, if I give you, if somebody types a shortened URL into the browser and then tries to access the bigger, URL, if that particular takes time, if the lookup itself takes a lot of time, it will not be a very good indicator on the website, because let's suppose it was basically a URL representing one particular event. Now, it's not a very good customer experience if they're just spending on the resolution time, right? I'm further slowing down the service of the end provider. So since I don't want that, I need the system to be very low latency driven, right? But it is not like people might think that we would need such kind of latencies in every scenario, but that is not a case, right? All the batch systems, for example, if you build, that can have higher latency. When you sign up for Netflix, for example, it asks you that, hey, what are your choices? Do you like to select some movies that you like watching, and based on that they give you some recommendation on the once you open the Netflix homepage. Now, the reason the same thing happens with Spotify as well. For those systems, the latency can be high. Like it is still bounded by some seconds, maybe 10 or 15 seconds, but it's higher as compared to just signing up on Netflix. You enter your email, you enter your password, and you're done. So depending upon the system you are building, you might have varying level of latency, and by varying level of latency, you can decide whether you want to build a system which is a batch system, or do you need a real-time processing system. So I'm taking a very simple example, but I hope you are getting at the point that using the same methodology, you can solve really complex problems as well. By the way, if you are interested in a very complex problem also, we take master classes. Those are free, completely free. You can join us in one of the master classes. It's a slightly longer format, hence we get to pick up slightly difficult topics than designing a URL shortener. So if you are interested in let's say building YouTube ingestion pipeline, that is going to happen tomorrow, right? So you can attend that. I'll be taking a YouTube, how does YouTube delivers its data to millions of customers which are globally distributed. I'll take a session on that on Sunday, so you can attend such kind of sessions. That will have a little more complexity as compared to what we are doing right now. This is the link for the masterclass. So anyone who's interested can attend the masterclass on Sunday. It happens on Sunday, 5 p.m. Right? There'll be a couple of more masterclasses which are listed. We take masterclasses on data structures as well. We take masterclasses on the system design aspects as well. Cool. So coming back to our original problem, coming back to our original framework. So we have discussed the design goals part of it. The next part of it is so before I tell you about the next part, how do you typically build a system, right? You don't, for example, if you have to run a marathon, you don't directly participate in a marathon. You maybe start to walk for a longer distance, and then maybe you start building up stamina, then you run 5 kilometers, then 10 kilometers, and then maybe you run for a 42-kilometer marathon. Similarly, in a system design concept as well, whenever you're designing a particular system, assume that everything, right from your storage requirements, your TPS requirements that we have identified in the step 2, all those requirements can fit in a single machine. Why do we make this particular assumption? This assumption is made because if you keep everything in a single box, that means you can have any kind of flexibility. The only thing that is reduced now is all the problem is or all the data can fit into single machine, which means you can use RDS. There's no need of optimization or anything like that. We'll identify what are the bottlenecks, and we'll iteratively build on top of it. We'll iteratively remove all the bottlenecks. So the last or the fourth point is basically you design for a single server. Whenever you're designing for a single server, you need to take care of DB schema. This is our based DB schema. Don't directly jump to any NoSQL system. it's a major red flag, right? So even if you have worked, thoroughly on Cassandra or maybe Redis or maybe any other database, it's a red flag if you directly jump to that particular database. Always start with RDBMS based schema, right? Once you have started with RDBMS based schema, then you move to designing the APIs and writing the business logic as well, right? Now, if I have to do the same thing for design schema and do all those things for our case as well, so let's do that here. So for the let's start with the API, right? What are the APIs that needs to be there? There'll have to be a post API, which would something be like shorten, and in the body I can get the URL and expiry, right? This would be the body. This is one API. The second API is basically a get API. Get is nothing but slash whatever is the short URL, and then there's no body in get, and you give long URL as the response. So these are the two main APIs that needs to be there. I won't spend much time into how we design that. That's a separate topic in itself. How do you design REST APIs? What makes URL RESTful? What does not make a URL RESTful? All those things we'll consider later. Like that's a topic of discussion for a different session. I won't go into that. Then you have to design the schema for this particular problem. The schema for this particular problem is a simplistic one table schema. You can have something like a short URL, you can have a long URL, and you can have validity, which user generated this, and maybe created at, and maybe some other 3-4 other tables. But the main columns are short URL and the long URL and the validity. Right? These three columns are the main columns. Using these three columns, I can answer both the APIs that I have listed out. Right now, I have done just a quick checklist. I've made the DB schema. I've made the APIs. The only thing remaining is using the what should be the business logic. Now, if you think about the business logic, this problem can be solved in variety of ways, right? One of the way to solve this particular problem is to have one ID field here, right? This ID can be an integer, and whenever you store something inside a database, that ID will get automatically generated, incremented to be precise. So it started with 1, 2, 3, 4, 5, whatever is the number, that is the shortened URL, and that will not go beyond. We are generating only 100K users per day and some 36 GB of data per day, which means that your shortened URL will not go beyond a certain limit, right? It will not go beyond 6 digits or 7 digits or maybe 8 digits, right? Whatever big URL you are getting, you just return the ID and that will be the shortened URL. But that is not a good approach, right? I hope everyone can realize that it will not be a good approach if you just rely on the database auto-generated ID. Why that won't be a good approach? Because that's easily guessable. So if I have, for example, I used your API and I used your API to generate a small URL, and then what I did was I just you returned me 54. That is telling me that hey, there are 53 other entries already present in the database as well. So I can just query using 52, 53 and find out who all are using your services. So it's easily guessable. So that's out of picture. The second approach. So first approach was basically relying on auto-generated ID, right? The second approach, which I think Rahul has also pointed out, is around using the UUID or maybe using the hash function like MD5 or SHA-256 and things like that. By default, we cannot use UUID. Why? It's a 32-bit character. Essentially, we don't require anything like this. Why? Because it is generating 32 bits of characters. I don't need 32 bits. MD5 also is 32 bits. SHA-256 is 256 bits. I don't require these many characters. Why? So let's look at how many numbers I can generate with one single character, or how many URLs can I store with one single character. With one single character, I have 26 choices of alphabets plus 10 digits, 0 to 9, 10 digits. So around 36 choices I have only with alphanumeric characters if I use it for shortened URL. If I also include the casing, I'll also introduce another 26 characters, which makes the total tally to 62. So with a single character, I can represent 62 big URLs. So let's suppose my big URL was this. I transformed it and I said that, hey, I will represent this big URL with A, and I'll store this particular mapping to in the database, right? Now, how many URLs can I store using two characters then? The first 62, the first character can represent 62. The other character can also represent 62, right? So it will be 62 into 62, which is equal to 62 raised to the power 2. How many for with 3? 62 raised to the power 3, and so on. How many with n characters? 62 raised to the power n. So even if I have 5, right, 62 raised to the power 5 is, I think, somewhere in millions or billions, which will do my job. In case I need more, I can add one more, 62 raised to the power 6 probably, and I will get my response. I will get my final. So Shivans Dubey says it will be 62 into 61. No, I can use A and capital A again. So for the other character also, I have the same, exact same. Repetitions can be there. Anyways, in either of the cases, 61 or 62, that really doesn't matter. What I was hinting, or what I was approaching from this particular discussion, was that there'll be exponential number of combinations that I can create with a limited set of characters. So I have solved one part of the problem, right? The part of problem that which all characters, or what should be my business strategy to come up with to represent million or a billion long URLs. That I have really solved. I've solved for that. What I've not solved for is the guessability factor, meaning that if I have A, if I return someone AA, or maybe a AB, right? Let's suppose I return AB. This really tells me that there has to be a URL generated with AA. So what can I do to remove this guessability factor? Any thoughts on that? How do I remove the guessability? So what I can do is I can generate multiple messages with, or I can pre-compute all the numbers, right? I can pre-compute everything, and then I pick up the first million, and then push it into a set, a hash set. A hash set will just randomize it, and then I can just iterate on the key set. Once I have accessed a particular code, I can save it in the database. That will basically ensure that that will basically ensure that guessability factor is removed and it is scalable as well. So that was my point number 4. How do you design system that can work in a single machine, right? Design for a single system or for a single server. Now, to add scalability factor, we need to, what can be the bottlenecks? That one server is not enough to cater to my high read TPS. In that case, what can I do? I can have multiple servers who are running this piece of logic, and each server is responsible for each server is basically responsible for generating its own version of code, right? So I can say, let's suppose I have running 26 servers, or let's suppose I'm running only 3 servers, server 1, server 2, and server 3. I give 1 million pre-generated coupons for this one, 1 million to this, and 1 million to this, right? So as and when I'm adding new servers, I'm giving this 1 million set of pre-generated codes that can be used by that particular server. While assigning this 1 million coupon codes, I can ensure that there is no collision. Once these codes are residing in the memory of the server, I'm not introducing any new latency, and I'm ensuring that the data, I have designed a low latency system that can scale to millions of users as well, right? So that was the basic idea, right? You go for first 4 steps, you gather the requirements, you estimate the scale, you find out what are the design choices or the design trade-offs that you need to make. Once you've identified that, the next step is to basically design your system that can work on a single system. That will involve writing some DB schema. That will also involve writing APIs and also finding what is the core business logic that we should support, right? Once that is done, then is scale for the numbers that you have identified in this step, estimate scale step. How do you basically scale for whatever you have decided? Once you have discussed all the approaches and all the problems, then you go back to the gather requirements, the MVP stage. In the MVP building stage, you have written some requirements. Just go through each requirements one by one and validate that whatever you've written is working fine, and all the features that you've discussed earlier are taken care of, right? So this was the basic idea. Now let's jump into the question, and I will stop the screen share. Yeah, so he was asking that while I was estimating the scale, won't I consider the read once as well? Because there were the number of users who are doing the read and the number of users who are doing the write operations are different. Hence, I think the question came that read once should also be stored. I think that is not required, because whenever you have to write something to a database, only that amounts for the storage. Read once you'll consider while calculating the TPS or throughput on your system. Then you'll basically have to consider the read request as well. His another question was that expiry of URL, would it be 24 hours, 1 week, availability must? So that's a valid question, which you should definitely ask when you're appearing for interviews. I didn't clarify while I was designing it, but I had taken the expiry from the client itself. Whoever is generating the URL can typically tell me that when is it that he wants this particular URL to expire. By default, I can have some, keep the link open for maybe years, but you should have a fixed expiry to all the, whatever you're adding in the database. And this is a very key concept if you think closely about it. Expiry can save you from adding or having to add multiple, shards as well. Why? Because if you don't have expiry, your data will keep on growing, right? It will go on a linear scale or exponential scale, depending upon how people are interacting with your service. But if you truncate older data, that means your same single database instance can serve the request as well. So that is actually very important, that you clarify with your interviewer that what is his expectation out of the expiry. Most likely, if he asks you to design a URL shorter, even expiry will not be a explicit ask, right? This is something that you as an interviewee should have clarity on. You should ask that particular question, right? Cool. Batch versus stream, when to use, right? That's a very interesting question. I think it actually depends on your use case, right? For example, in some cases, batch processing does make sense. I'll give you one example, right? For example, ClickBuzz. Let's suppose we have a website like ClickBuzz. Now, ClickBuzz have started, let's say, one game wherein people can play or people can chat live during or comment on anything while the match is going on. After the match is over, they'll find whatever or whoever has the maximum number of like on a particular comment, they'll reward that particular user. Now, in this case, either you have both options. Either you can stream all the comments that are coming and then have an aggregate on number of likes each comment is getting, or since it's a one-off activity after which is supposed to happen just after the match, you can also use a batching system here. I would use a batching system here solely because it's a activity which will happen only after the match, right? If you see IRCTC website, that goes down after 11:30 p.m. every day. That is because they want to reconcile everything. It's a batch process. The salaries, for example, are a batch process. Where I would need a stream, I think a stream processing engine would make sense. For example, if I want to do some cloud deployment and I want to check whether in real time, are there any security anomalies in my cloud deployment, right? Or for example, any kind of an audit that I want to maintain, right? For example, if somebody launches a EC2 instance and he has attached a public IP to that particular instance, that is an opening into my VPC cloud, which is a security threat. And ideally, I would want to catch it in real time. So over there, I would go for the stream processing engine because I want to have a live action defined for every outcome that is happening. Right? Okay, I think that's a very good question. His question was when I was defining the schema, right? When I was defining the schema for my URL shortener, I didn't add ID. ID I added later only when I was, going to the business aspect of it. But a quick yes or no in your mind, just keep a yes or no in your mind. Do you think a primary key is required in this case? Let's talk about yes and its implication of having a external ID. If I have an ID internally, all the MySQL or RDBMS system, what they do is they sort the data physically based on ID. So ID 1 will be placed closer to 2, will be placed closer to next to 3, will be placed next to 4, and so on. So this helps in fast retrieval of data because they are able to look up for that particular key in a very fast manner. Now, my primary lookups, I have seen this many people doing this, that they just add ID for the heck of it. There is no real use case of it, right? For me, my ID is the most of the time my requests are going to be short URL. What given a short URL, what is the end long URL? That is going to be the reads. To optimize for that, I'll keep the short ID as my primary key. It is unique, right? And I want the data to be fetched using that. Hence, having an explicit auto incremental or any kind of other ID is not required. Just having a short URL will serve my purpose. So if you want to go deeper into it, just read about locality of reference. It's a very important concept, primarily used in DBMS systems. So you can typically go ahead and look into that. UUID, Hashbase, and all those systems does not work solely because they generate 32-bit numbers. And let's suppose I skim the last 5 or last 6 also, then also there'll be many chances of collisions. So dealing into those areas will just be problematic. Pseudo random number generators. So for anything that you're doing with randomness, right? Either the range has to be a lot, meaning, for example, for 32-bit number MD5, that is basically a good enough hack to generate a 32-bit unique number, or I can go with UID and generate a random number. But if my range is limited, now let's just to give you an example, let's say I have only two numbers, 0 and 1, and I ask you to generate a random number between 0 and 1. You generated 0. Let's suppose the first number that you generated was 0. I again ask you to generate a pseudo random number. Let's suppose again you generated 0. And again I ask you, and again 0 was generated. Right now you just have one number remaining, and there are many chances of collisions. There are 50% chance of that you generate the number which was already generated before. Now let's increase the range of your numbers. Now you have 0, 1, 2, 3, 4 numbers, right? Let's suppose 0, 1, 2, these 3 numbers are already generated. The probability of generating a new random number which has not been used earlier is just 0.25. 75% chances are there that he'll generate the number which is already generated. So as you keep on exhausting the available resources, the operation which was already O1 operation is basically tending to ON, right? You can take n chances to generate that particular number. If you have 100 numbers, the probability of one number getting picked up is 1 by n. So if you have out of the first 100 numbers, you've filled up 99, the probability of generating the number which is not used randomly is very, very less, right? So it's 1 by 100. So you have to take 100 tries, then find out that particular number in a best case, in a probabilistic kind of a case scenario. So that's not a very good, way to find it out randomly. Randomness helps you in some cases, but randomness is not a good enough criteria. So you can search for this particular problem. It's a very famous problem asked in interviews as well, asked in coding interviews as well. That if you have one array, one and you want to pick up random indexes in an equal probability. So let's suppose you have numbers from 1, 2, 3, 4, 5, 6. Out of these 6 numbers, you want to give equal probability to each number and find out and generate a random number out in this. How would you do that, right? The standard way of doing that is you always generate a number from, since you had 6 places, you generate a random number from 0 to 5. Whatever is the index, let's say 3 is picked, you swap 3 with the last element and you decrement the range. Earlier, the range of finding out the random number was 0 to 5. For the next iteration, it will be 0 to 4. For the next iteration, it will be 0 to 3, and so on. And you keep on swapping the index of element which is getting picked with the last value. How is the server assigned a set of million records out of all the possible records? I think I have discussed this problem very briefly. You can generate all the sequences, first million sequences, then second million sequences, and third million sequences. Whatever is the sequence that you've generated, put it in the hash set. Hash set will automatically rearrange the keys, right? It is not a list typically keeps everything in order. If you put it in a hash set kind of a data structure, it will automatically jumble up the records that you're getting, and that will basically ensure that you're getting a random ID every time. Batch processing would be Amazon order, salary, stock market, yes. Stream processing, live sentiment analysis. Sentiment analysis also can be done using batch processing. Might not be yeah, it actually makes sense if you want to triage or maybe alert or mark as misinformation on Twitter or Facebook these days. So yes, you can use sentiment analysis, which can be streamed. Let's take this question. He says, if we are pre-assigning the short keys, won't it be time taking for searching available key to assign as if we were trying to create on a particular second? No, so let me explain this process. Let's suppose these are my available slots. Now, what I need to do is, whenever a request comes, I need to pick one number out of it randomly, right? And assign it to the incoming request. This is stored in memory. In memory meaning this is stored on the same server on which my application server are running, right? So let's suppose the first request comes and I generate the random number. The random number which was generated between 0 to 6. I generate a random number between 0 to 6, and that returns me 2. So what I do is I return 2. 2 is now assigned to the big URL, and I move 2 here, right? So 2 comes here. So 2 comes here, and 6 comes here. All right. So the new array now becomes this. Next one number again comes. So what I'll do is, now I'll decrease the size. Size is till this. So I'll generate a random number between 0 to 5. Let's suppose the number that came was 1. What I'll do, I'll move this 1 to this. I'll swap the two numbers. What will be the resultant array? The resultant array would be 5 will come here, 1 will go here, and size minus minus. If I have to generate new next random number, what I'll do, I'll take random of 0 to 5. Let's suppose 1 is generated. Now 5 and 4 will be exchanged, right? So the data will become 4 here, 5 here, size minus minus, and so on. I can just continue this. So using this way, I can, find out, generating a random number between two numbers is very easy, right? It's an O1 kind of an operation. So using this particular approach, I can find out keys and I can ensure that the guessability factor is maintained to a certain extent. And how do I distribute if I have multiple? Let's suppose I just have 10 buckets each. So how do I distribute? 10 buckets means that one server, let's suppose, can handle only 10 keys. How do I distribute them? I have a list of 200 URLs that can be generated. I pick the first 10 and I send it back. I save this 10 in the first server. That is how I can ensure that each server has 10 keys to work with. All right, guys. Thank you so much, guys, for joining in. Bye bye. All right, we are live. Hello, everyone. I am Mohit Yadav, and today we have with us Lokesh, who will be mock interviewing with us. The topic for today would be a topic around system design, and I let you introduce yourself and tell me something about yourself, Lokesh.
Hi everyone. My name is Lokesh. I'm currently working as senior software engineer at Akamai. So I'm totally having 6 years of experience. So prior to Akamai, I worked at Big Basket. So currently at Akamai, I'm working as full stack developer. So I'm graduated from IIIT Newsweed in 2015. Yeah, so that's it about me.
Sure. Cool. So I'll just quickly tell the format for our viewers as well. I'll be asking questions. Lokesh will be answering me, and wherever I feel that I can, add some valuable feedback, I'll probably give that feedback to you, Lokesh, and to the wider audience as well. Right. So
Sure.
instead of giving the feedback and keeping the feedback for the last, I'll probably keep on giving the feedback as and when we go around. Right. Cool. So I think there are a few users who have joined us. Let's wait for a couple of more minutes before we get started. Meanwhile, I'll also share the screen. So whenever you talk about, if there's a need to draw something on a whiteboard, I'll use my iPad to draw that particular thing for you. For example,
Sure.
if you say a load balancer, I'll draw a load balancer for you. If you say something
Sure.
other things, maybe application servers or databases, I'll draw those databases as well for you. Right.
Sure.
Cool. So let's get started. The question for today is: you need to design a Google search type ahead. How would you go about designing that?
Okay, so basically, so if I look at the requirement, so basically, when users type something on UI, so he needs to get the list of suggestions. So in the drop down, so that's the basic requirement. And coming to the suggestions, so the first thing is the suggestions should be sorted by the popularity in the decreasing order. So the most popular should be at the top, or the most search or most popular.
Okay.
um, so and also sometimes, I mean, we also need to take care of the muted words. So I mean, we don't want to show some pirated or some adult, so some kind of words we don't want to show, so we need to filter them. So that's also one requirement, so we need to filter them.
Okay.
So I'm just thinking, so popularity and so I think for, I mean, for this, so I'm assuming we need to display top 10 popular words, I mean popular phrases only.
So
um
let's just say top five would do.
yeah, okay, fine, yeah,
Top
top
five.
5, yeah, top 5 words.
Right.
And so yeah, and also the most important thing is, it should handle the typos. So if we make any typos, the user make any typos, so it should handle that. So that is one word, I mean one requirement. Yeah, so so I'm assuming this is the scope of this system, I mean,
Okay.
as per the functional requirements. um so and
Anything
so
else that you see in a typical Google search?
mm,
For example, if you search for weather and I search for weather, we'll be shown different results.
Okay, you mean the informational results. So should we also
Right.
consider, is it like
Correct.
so? Okay, so that means, like, Prime Minister of India. So in the drop down, we'll get the answer for that. So you mean those
Not the
information?
answer. For example, if I type Prime, I watch prime time news a lot. So for me, the suggestion can be prime time. let's suppose you search Prime Minister a lot.
Okay.
So for you, Prime Minister will come.
Okay. 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 Got it. So using the cookies, so user cookies or personalization. So user
Correct.
personalization recommendation. Yeah. So
Right.
personalization. Yeah, that is true. That I missed it. Yeah, that's one of the thing. And um so also we should we consider the location based search or
Yes, we can.
not? Yeah.
We
So we
can.
can.
So this is basically the first phase, right? Where we just
Yeah.
scope out that just by looking at Google search type ahead, these are the 5 things or 10 things that are coming to my mind.
Yeah.
Now, in order to discuss it in a 45-minute interview, it is not possible to go and design each and every
Yeah.
feature. So we'll just
True.
limit the number of features that we are going to discuss. So I'll
True.
cross out popular. We definitely need to sort the result based on popularity. That's a must-have. We
Yeah.
don't have to filter words. We can assume that filtration is not required. So
Okay. Yeah.
this is something that we can remove.
Okay.
Top five, again, top five is a primary requirement for Google search, so we need to have that. Typo handling also we can ignore. Personalization and location based, suggestions are also something that we can ignore for now. Right?
Okay.
We may
Okay.
discuss it if we have time towards the end, the
Exactly. Yeah.
personalization bit, right?
Yeah.
So let's start with these two, popularity and top five.
Yeah. So these are the functional requirements, and coming to non-functional requirements. So basically, so the system that I want. So the first of all, I mean, if I go by cap, so the system should anyway have to handle the partition tolerance because of the network failures or any failure. So the partition should be always there. So
Okay.
and then if I want to choose, that means, I mean, basically, the scalable. So I'm actually choosing scalability to be my first priority, and also so over availability and consistency. So for this case, I actually go with availability. The reason being why I do not go with consistency is because so I mean, like, eventual consistency is okay. So instead of strong consistency, eventual consistency is okay for this system. I'm thinking why, because I mean, sometimes I mean, even though if we are not, so let's say we have some top five results, but let's say I mean, we are showing, let's say the incorrect one. Like, in the, let's say, there is a term which is top five, but we are showing top six, or I mean, one, I mean, which is misplaced. So that is fine. Like, it can eventually propagate, and we can show. So that's why I'm actually going with availability and the scalability.
Okay.
So, and coming to scale estimations. uh I'm actually, so first of all, the number of requests. Basically, since it's a scale of Google, I'm thinking maybe some 5 billion requests per day, at the scale of Google, I'm thinking.
So how did you come up with this particular number?
I mean, so basically, I just came with random, because so obviously, the request will be billions, I mean, taking Google search. So that's why I came with, like, some 5 or 10 billion. So 5 billion I came up with.
Okay, a good way for scale estimation, right? This is
Okay.
I'm basically giving you feedback. A good way to do scale estimation is to look at the daily active users,
Yeah,
and then
exactly.
deduce what are your TPS and storage requirements would be, right?
Yeah.
So Google has I think close to 2 or 3 billion. Let's for the sake of calculation, let's assume that Google have 1 billion users, and every user maybe queries at least once a day, uses
Yeah.
Google search at least once a
Yeah.
day. So there will
Yeah.
be 1 billion queries uh, per day. These are the reads. and every read
Exactly.
is contributing to the write as well. So I'll leave
Exactly.
the thought here and let you continue the thought.
Exactly. Yeah. So this system is actually uh, read and write. I mean, so read and writes are equal here. So that means 1:1, and so that means here it is one. So we are so thinking. I mean, we are having that 1 billion requests per day. I mean, because we are having 1 billion users. Coming to coming to the storage. So I think we can leave this here, and then coming to storage. In our system, so we only need to store the queries. I mean the votes or the queries. So for that, I'm thinking, so maybe so each query at max may not store may not take more than so maybe like since they're strings, and they actually, I'm thinking maybe like less than a kilobyte. So that means like something like um, some 512 bytes or something. I'm thinking like half a kilobyte. So each word. So that means we are having 1 billion requests. So 1 billion into half, I mean into 0.5 kb. So which will, I think, I need to calculate. So
This will
something,
be something in terabytes, but is that
yeah.
calculation correct? Uh, because although we are getting 1 billion search queries, do you want to relook at this number? Because all of them are not unique.
Yeah, exactly. So yeah, all of them are not unique. And in our system we don't write them. I mean, so we don't write all of them, so we already may have other info. So that's why I actually so I mean the maximum threshold. So let's say we got a word or we got a phrase in the worst case that is not in the system. So in that case we have to store the whole word. So that's why I came up with less than a kilobyte, so around maybe some 256 bytes or something.
Okay.
I mean 0. Yeah, so 256 bytes. So at maximum, I'm thinking.
Okay. So we'll leave the storage part here. Let's move ahead. Let's just assume that one box is not enough to handle the entire storage data.
Exactly.
Okay.
Exactly.
Let's just assume that there were some issues with the storage. The issues were that you are reducing the size of the particular record. Instead, then what I'm arguing on is that you won't be having 1 billion records to write. Because let's say
Exactly.
I search for Michael and you also search for Michael, that will end up going in the same direction. I'll just upgrade the frequency. But let's
Exactly.
see the design first, and then we'll come back to the storage part later.
Yeah, sure.
Yeah.
So I'll go with the first, go with so the basic design. So basically when we so we can actually think of the first thing that comes to to our mind is try. So I mean, to store them in a try. So it's very very trivial and obvious that I mean, by looking at the question. So that means we have to use try. So basically we'll have one node, and for each node we'll have we'll store them. Yeah. um so um let me first try. I mean, let me first go by I mean the flow. So basically the user sends a HTTP request so with the votes in it. So let's say user searches with Donald.
Okay.
So as you written. So basically I mean, initially I'm assuming that I have only I mean, I don't have large scale, but small system. So basically so the client sends the request, and I actually go and look up the try. And each lookup I actually try to find uh, so I mean, if it's a successful match, that means if it's a successful vote, so then I actually update the frequency at the terminal node. So basically we know that in a try, we actually store a boolean called is word to tell whether that's a word or not. So basically, yeah, so that's a word. So whenever it ends there, so in our case we also store the frequency, so which will be updated incrementally every time. uh, so and
So one quick
yeah,
question over here. So you said that let's suppose the search query is Dawn here, right? And there is a null character over here as well. That means Dawn is also a valid word. So you
yeah.
suggested, let's say, two words, Dawn and Donald, and he clicked on Donald. So what all, where all? Now I think each node can have its own frequency.
So
Each
each
terminal node,
node,
each node means
yeah,
each terminal
each
node
terminal,
can have its
yeah,
own frequency. So
yes.
which all frequency would you modify?
Yeah, so you're saying when user enters Devo and Don, so we'll suggest Don and Donald. So
Right.
if user clicks on Donald, so which we will increment, right?
Correct.
Yeah. So in this case, since user selected Donald, so that means will increment the frequency of Donald. So that means the D terminal node, because I mean
Right.
that's where that is getting hit. So this frequency will hit. I
Correct.
mean, however, there are still problems with this, but we'll eventually find it out. Um, so this is the basic approach. Uh, so
So what are the
so we,
problems with it in terms of,
yeah,
so what I want is top
exactly.
five. How would I like, what is the complexity of your current solution basically?
Yeah, exactly. So here the problem would be, so when I want top five, so I actually have to traverse the whole tree.
Correct.
So that means, so let's say when I said like DON, so that means from N, so I need to actually traverse through I mean whatever the depth of that a tree, I mean located at N. So I need to look them, and then I need to find the maximum of them, and then again I need to return them.
Right.
Here the problem would be drilling down the tree. So I mean we need to find, how can we resolve it.
Right. So
uh,
first of all, first question is, how would you find top five out of, let's suppose you are doing the iteration also.
yeah.
How would you actually find the top five elements?
Okay, so you mean
We can do iterations. This is as good
yeah,
as I have an array and I
yeah,
need to find top five. So
exactly. So the main thing, and also basically when I came across this top or I mean uh, kth largest of this, so I actually think of building heap, but again, so I'm thinking, so I mean, so can we store this information in each node, like, so as we build the try, can we actually store, so say at n, can we actually store the information that, okay, so top five votes at n are these, can we
okay.
actually store them? I
So
mean, so yeah.
which data structure would you use to store that?
So here I'm thinking, it would be enough if we can store the references of the terminal node. So let's say, so n at n, so d is another terminal node having some good frequency.
Correct.
So here we can uh, see here we can use a heap, uh, a max heap.
Okay.
So a max heap.
Max
So
heap.
we can,
Okay.
so the top
Are
will,
you sure that you'll use a max heap for finding top five?
so because here we need top by the decreasing, I mean by the decreasing order of the popularity, right? So
Correct.
that means every time I actually remove the maximum at the
Mm-hmm. I lost your voice actually. Hello. Yeah.
hello.
Now now you're audible.
Yeah,
Uh,
am I audible?
yes. Yes. You're audible.
Hello.
Yeah, hi. Hello,
Hello.
hello. I can hear you fine.
Hello.
Hello, hello. Uh, it's a recorded session. How can you say it's live? It's not a recorded session, Sahu. It's actually live. Uh, I can hear you, man. Lokesh, hi. Hello. Can you hear me? Uh, Facing technical challenges, guys. Just bear with us for some time. Can you try reconnecting, Lokesh? I'm able to hear you fine. Meanwhile, I'll just take questions that are there. So, locations based personalized search, yes. Fast response time, yes. Hey, Lokesh, are
Hey.
you? Am I audible now?
Yes, yes, yeah. I think
Yes.
some glitch. I mean, yeah, fine.
No issues. We are back. So we were discussing about that. You said we'll have a max heap over here,
Yeah,
right? So do you see a problem in that? I'll give you some numbers. Let's say these are the numbers: 4, 5, 3, 0, 6, 3, 6. All right. And let's suppose you want to find top three elements. So you
yeah,
try building a heap. So you added 4 in the heap. Then you add
yeah.
5. So you 5 is added. Then you add 3. 3 is added. Now comes the value of 0. Should 0 be added or not? How do you decide that?
Okay.
Basically, you'll have to check
So,
all the elements in the heap to do that, right?
wait. So, okay, you're saying, so we want top three, right? So, okay. So yeah, in this case, we will check. Uh, yeah. So basically, we need to check the minimum element to find, but the minimum is not at the, yeah, maximum is at there.
Yeah,
Okay, okay, yeah, that's true. So if we find three, yeah, that's true.
that's true,
So
right?
hmm.
Yeah.
So when it came six, so we'll check with three. If it is greater, then yeah.
Yeah. So instead of this, what we could have is a minimum heap,
Yeah,
a min heap basically. So 4 will be there, 5 will be there, then 3 will come. So 3 comes here and 4 comes here. Then
yeah,
0,
we can.
0 is not greater than 3, 6 is greater. So we'll remove 3 and we'll add 6. So that's how it will be done.
Yeah,
Cool. So every node will have a min heap attached to it. The size of the min heap will be 5.
yeah,
Till that, we have solved the problem. So using that, we can typically answer our query in an order one time,
yeah,
right?
yeah,
So
exactly. Hmm.
cool. So till that we are clear. What about what can we do after that?
Yeah. So this is the basic design.
Right.
So I mean, like I'm thinking about, what else. I mean, what other problems do we have with it? So I mean, when we scale this up, so the main problem would be the storage. So like, how do we store? Try. How do we handle such a huge use scale? So basically, so one thing so one thing we can do is we can actually replicate the try. I mean, we can actually use like master slave approach by
Mhm.
having, multiple copies of tries. And then we can propagate, like just like how in databases, so we can write to master and then schedule to slaves. So that approach we can do. I'm thinking the problem would be, so the latency would be more in this case. Like,
Mhm.
uh, so I mean, writing to so there can be replication lag, so we can add to the latency of the user. I mean the consistency can be little compromised. So this is one approach. So and also one more thing is, so this is okay, like so this is okay when we can store the try in a one machine. But so but what about if we have to partition that, so that also we need to consider.
Yeah.
So what
So
if it
let's
exceeds?
break it down. What are the problems with this particular approach? Let's write down all the problems and then we'll discuss
Yeah,
one by one what can be the
yeah,
probable solution. So what are the problems? Can you identify the problems and tell me what those are?
yeah. The first problem is so I would say the data partitioning.
Uh, okay. So I'd say storage,
Yeah,
right? What else?
yeah,
That
storage.
entire data, the entire try that we are building cannot fit into one machine because we are storing the search, like we're storing the try of all the searches, right? So that is one problem. What is the other problem?
Yeah, so that is one problem. And should I also consider on the client side, like what issues we'll have on client or not?
Not the client side. We are designing the backend, so let's focus our
Oh,
discussion
only
on
on
the.
the back. Okay, so and also caching. So I mean, should we have to cache some queries or something? I mean, should we implement
Okay.
caching here?
So what kind of
Um,
caching are we uh, doing here? This is a try,
I,
right? So try would be stored in memory, so we don't require a cache.
so I mean, like, so I mean, if there are some popular things, so we can actually return, I mean, we can actually store some entries in cache, and we can write it to try asynchronously, I mean, to increase latency. Because I mean, the main requirement of the system is to have less, I mean, low latency to the user.
Hmm.
Because if you, I mean, as the users are typing, it should come in milliseconds. So I mean, what if we store the I mean, like, popular ones on cache, and then we update them in the asynchronously to the try.
If you say, how would you identify the popular ones in that case? Is basically what you're saying is that maybe for some queries you'll save data somewhere, so that those are anyways the top 10 or top 100 or top 200 or maybe top 1000 queries. You'll store it separately, and whenever the term comes, you'll give the response from there. But let's focus on the main problem. The main problem is that we need to give a consistent
Okay.
response for every system, right? We don't have to optimizing for some queries. We can do it later, but let's
Okay.
optimize for the larger set of problems. So, apart
Okay.
from
Okay.
storage, do you see any other issue in this particular approach?
Yeah, I'm thinking. So storage and so we so I mean, so main thing we need to improve is latency. So that's the main important thing so in this system. So for improving latency, I'm just thinking, so what else we can do?
So we identified. Uh, do you think updating these top five, when we are updating the
Yeah,
frequency of a Donald,
yeah, that's true.
we
Yeah.
need to update
Hmm.
D, L, all the nodes, right?
Exactly, I'm coming there. So so when we are updating the updating one terminal node, so
Right.
we need to traverse back I mean, so many levels to find each terminal node and so on to till root, maybe
Mhm.
to our, I mean, sometimes, and we need to update this top page. So these updations are yeah, I mean, are so here that's one problem.
So you said we need to update terminal nodes. I think we need to update every node that's there in the path till the top node. Why? Because even if a person has typed DO, there should be a heap
Yeah.
corresponding to
Yeah,
O,
that's true.
which can give
That's
you
true.
the node reference, right?
That's true. That's true. Yeah,
So
that
we'll
is true.
end up updating L, A, N, O, and right up to D. So for
Yeah.
one read, I am actually doing multiple write operations.
Hmm. Yeah, that's true. I
And
mean, so these.
while
Yeah.
I'm updating this, do you think read can succeed?
So 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 you mean like, so we will not so we'll not update them in sync way, but we'll do it in async way. So we'll just return the result, and we'll so use asynchronous way to update those nodes. But that still be a problem, because updating those, I mean, so considering the scale, the number of requests, so the updations will be a lot.
Mhm. So, basic thing, right? Let's suppose I have one database. This is a chunk of database. I have a value of x equal to, let's say, 5,
Yeah.
right? Uh, People can come and read the value of x equal to 5. There can be multiple
Yes.
read threads that can come and read this particular value. Now, let's suppose
Exactly.
there is one thread which is trying to update this value. It wants to set the value of x equal to 10.
Yeah.
Unless this value is written, all the read threads will have to wait. They cannot read this value
Yeah,
of
that's true.
x. That's true. So if I have to
Yeah.
update the value of all the nodes, till the time I will not be able to serve the reads as well.
Yeah, right. Yeah, that's true. That's true. Yeah, I mean, so in that case, yeah, Reese has to wait till these are harm. That is true. Yeah. So.
So
Hmm.
my problem is how to make this a read intensive. It's
Read.
a read equal to
Yeah.
W kind of a system. I want reads should
Yeah.
be greater than W, much greater than W. What is a way to do that?
Okay. So to optimize reads, how can we? Okay. So question is like, to optimize reads. So I mean, how can we optimize reads? So I mean, when we have
Yes,
more reads.
yes.
Um.
Can I mold my system in such a way? Can I have some kind of a design trade-off added here, which will make my system more read friendly, and I will do writes only after. Like I need my writes to be very less as compared to the reads.
So how can, I mean, what if we have, I mean, instead of storing a big try, so what if we have, I mean, because when we are writing in a big try, one made in one try, so what if we,
Mhm.
I mean, if we chunk it and store the chunks, and based on the ranges, if we go to that particular try and only update that try, so that we are reducing the blast radius, right? So we are just reducing it. So
So
I'm. Hmm.
not sure how that would impact the number of writes. So right now, what we are doing, I'll give you a hint. Right, right now, what we are doing is whenever a person clicks on chooses one suggestion, we are updating that particular frequency over here. Do
Exactly.
you think that it makes sense to update the frequency every time a user clicks on a suggestion? By the way, guys who are
um
looking for what
okay.
the question is we are designing a search type ahead. Yeah.
Okay, yeah. I mean, if we do not update, so then the subsequent reach will not get the top. So I mean, so uh when we are reading, so you're saying, instead of updating, maybe we will update later, or in I mean, in some intervals we'll update. uh
Mhm.
I mean, we'll just store them and then update in regular intervals, maybe.
Yes. Yes.
Saying.
How? Yes, that you're going in the right direction. Where can we store it? How can we store that?
So basically, so whenever user clicks on that, so we are actually updating. Instead of that, we'll store them in some message queues or something. So then, in some message queues, and then we will actually have consumers that consumes maybe every hour or some regular intervals to update them.
So even that, when you're storing in a queue, that also has a problem, right? Some consumer will read that message and then come to update this particular try that we have, right? Instead of that, why not store it in a hash map? Can you use a hash map to store it somehow, and then after some frequency or after some threshold, you update the complete frequency?
Yeah, but so you're saying with message queues will have some redundancy, is it?
No, so for message queue, let's suppose I store it in a message queue. There
Mm-hmm.
is a Donald message here. There is a Donald
Yeah,
message here. There is a Donald message here. So I'll end up, whoever is consuming my message will end up updating the
yeah,
queue the same number of times you have pushed the message. So my
yeah.
rights,
That
I'm
is
not
true.
decreasing the rights.
Yeah,
Can we use,
that is true.
make
That is
use
true.
of a hash map and decrease the frequency of writes?
Yeah. So in this case, we'll have a map that will have the that will have the frequency of each word
Yes,
in that regular interval, and then yeah, we will update in one shot. So
correct.
I mean one shot we can update. Yeah,
That's
that is
so.
that is
A criteria could be that we only update once my frequency reaches beyond 1,000. And 1,000 for a billion, if I consider billion search
yeah,
queries, 1,000
yeah,
is a very, very small number, right?
yeah,
So I
true,
can
true.
afford to have a error margin of 1,000. I don't need to,
Yeah,
it need not be a very accurate margin as well,
yeah,
right? So
true.
just keep updating the frequency in a hash map, and once you reach, let's say 1,000, you update for that particular keyword. So for Donald, you'll just iterate through the tie and update the frequencies
Yeah,
plus
exactly.
1,000 to whatever it was earlier,
Yeah,
right?
exactly.
Cool. So my one problem is solved about the write part. Now my reads are more, so I can add more parallelization. I can have I'll basically have lesser number of writes. So that
Yeah,
inherently gives me an opportunity to cache or do all sorts of optimization.
yeah.
But we still have this problem of storage. That entire
Storage.
try, I cannot push the entire try in a single box.
Yeah, yeah, that is
So
true.
how do
So
I
yeah,
get rid of?
yeah. So like we can actually partition it in such a way that maybe I mean I'm just iterating some possibilities, and we can actually look at the pros and cons. So one is
So,
so range based partition, like all A's or all B's at once. But this will not scale well. Why? Because let's say the votes at with starting with X or W maybe less than the votes starting with other alphabet. So again, so that will be a problem. So or we can actually take prefixes and store by prefixes. uh,
okay.
so maybe like so A to like from like AB to AD or something, so those prefixes if we store.
A to, let's say, K is something, L to M is something, and X to Z, something like this, right? Maybe
Yeah.
basically bucketing. You're basically creating the buckets.
No, I mean not like that, but still, not with length of one, but maybe three. So let's say, so there can be words like so like starting with cat. So and again, there can be many words. Maybe let's say some millions of words, and if so like taking the prefix and storing by those prefixes like so AB or ABC and so on.
So I think AB is stored in one, and then AC is another one, AD is another one, and so on.
Yeah.
Okay.
So
So let's
yeah.
suppose with this I'll have six. Sorry. 26 into 26 characters. These many
machines. Yeah.
combinations I'll have, and it is not really necessary that I might have more machines, I might have lesser machines,
Yeah. That is
right?
also true.
So how
Yeah.
would you
Huh.
map this number with the number of machines that I have? Let's say I have n
So,
number of machines. So how would you map this? Uh, let's call this x number or x number of prefixes with the n machines that I have.
so we can actually do by hashing. So for a word we can have a hash function.
Mhm,
So that can actually, so when we store, so basically we'll not store all those abs in one machine, but so basically what I'm saying, so let's say we'll determine, so words starting with prefix ab, or AC, AD, and so on. Some k number of prefixes will store in one machine. So I mean, like that, we'll store in multiple machines.
mhm.
Uh,
So the question over there is, I think what you're hinting at is that there'll be out of these, one machine will hold multiple prefixes as well. But
yeah,
how would you decide? Let's suppose I have prefix AA. On which machine this particular prefix should go? How would you
yeah.
determine that?
So basically, these machines will be behind a load balancer. So where my load balancer will maintain this mapping. So this with that mapping, the load balancer can relate to that particular machine.
Okay, so basically there is a load balancer which is sending it to one of the machines that is available,
Yeah,
right?
yeah,
But in the load balancer also, most of the load balancers are primarily stateless. So
stateless. Yeah,
you need to have a stateful kind of a load balancer over here. So do you
yeah.
know how to do a load balancing in stateful system? I'm just looking for one specific term. Anand Kumar R, you are right. You use the right term. So basically, the term that I was looking at is consistent hashing, right?
Yeah, I mean, I was coming to that. I mean, as I said,
Right.
hashing there. So I
Right.
mean,
So
I'll actually eventually come, but this I got it. Got in my mind. Like, yeah. So consistent hashing we can do.
right. So we will use consistent hashing. You still not answered what would be the shard key on what particular parameter. I think this is your shard key, right? AB and AA and EC. That is what your shard key. But what will you call that? Again, looking for a specific term. You've answered that in your previously.
Okay. So I mean, you're saying these prefixes. What do we call
Yes, prefixes.
them?
Prefixes is what I was looking at. So prefix becomes my shard key, right?
Yeah.
And once I have these prefixes ready, I can just push it to a consistent hashing ring,
Yeah.
and it will distribute the load evenly, and it will take care of how many number of servers are there, how many number of servers are not there. So we have
Yeah.
correctly stored storage problem as well.
Yeah.
Any other problems that you see?
Mm. So I mean, can you go up? So the scope is only top and I mean, I
Yeah,
forgot the scope. So only top
top 5 and popularity.
and popularity. Okay. So popularity problem is solved, and top is also solved.
Right.
So, and we'll do optimization. So I mean, like as of now, I don't think so much problems here. So I mean,
Okay.
because the basic design is fine. Like we can apply optimizations on these.
So we have introduced sharding. What if, let's suppose, this particular application server is holding AA, BA, CA, and some more data. What if this server goes down?
Yeah.
So how would you ensure that if this server also, if a server goes down, then also your system is done?
So I need to copy. I mean, I need to have these keys in another system. So that's
Correct.
one. I mean, right. So um,
How do we do that?
1 minute. So I forgot that. So
This is nothing but replication, right?
yeah. I mean,
This is replication.
so that means we will. That means we'll keep the replicas in other machines also, right?
Yes.
Or each one. I mean,
Yes.
each
So
of the prefix. So go.
each of the prefix can be replicated to multiple servers as well,
Multiple servers. Yeah,
right?
that's what.
So
Yeah, I mean,
and that is how we can define how we are basically replicating. So I'll quickly ask you a question on consistent hashing itself, right? So let's suppose these are my server IDs 1, 2, and 3. All right.
yeah.
Now let's suppose I have one object over here.
Hmm.
Okay, this is key 1. I'll use a different color. This is key 1. Okay. Now this K1, on which server will this data will be stored for K1? Either you go in the clockwise direction or you go in
Clockwise
the
or on anti-clock? Yeah,
or anti-clockwise. So let's choose one convention. Let's go in the clockwise direction and let's store
clockwise.
it
Yeah,
in 2.
two.
So 2 is holding my data.
Yeah.
What is the next server? If let's suppose I set the replication factor equal to
Hmm.
2, that means 2 server needs to hold the data.
Yeah.
What would be the next choice of server? Should I push this data to 1? Should I push this data to 4? Should I push this data to 3? 2 is the ideal candidate. I have added the data, but I need one more server to hold a copy of this particular data. Which server out of the other 3 available is the best candidate for that?
Okay. Okay. So,
Your options are 1, 4, and 3. 2 is already holding the data.
okay. So now two is holding. So, so if we assign to three, so the problem would be. So if we assign to three, the problem would be since we are going in clockwise. So if two is also went down, I mean for two, we again have to store them. I mean store the replica of two in some other machine. But I mean storing in the clockwise would be a problem here because I mean if two goes down, so we will I mean we'll have three for it. Um, oh, wait, I'm not able to.
So you're going in the right direction. So where will this K1 be routed if 2 goes down?
So it will be routed to three. So in the
Right.
clockwise it will be routed to three.
Correct.
So that means if we store at three, so if three also goes down,
Then it's a different
so
problem.
yeah, so that's a
We'll
different
we'll
problem.
solve
But
one
yeah,
problem at a time.
yeah,
Right
yeah, I
now,
think
if 2 goes down, there should be we don't need to
three.
transfer the data from 2 to some other node. My my newer queries will be routed to 3, and 3 already has the data,
Yeah,
right? So
yeah,
my natural choice becomes 3 in this case, right?
exactly.
Right. Cool. So yeah, I think that is we've discussed enough on this. There is one more way to decrease the number of write operations.
Uh-huh.
Can anyone, you or anyone who's joined us, tell me one approach which we can use to make this property hold true? Right now, if I don't do anything, writes and reads are same. I want a system where my reads are much greater than my number of writes. One way that we have discussed is the hashing approach. Can you guys think of one more way to do
So
this?
as you said, hash map. So similar to that, maybe map reduce kind of thing we can use. Like we'll have a map, and then those reduced jobs will write it down to them.
What is your mapper step here?
I mean, so whatever. Okay, so in this case, so the mappers will be. I mean, so maybe if we can store the votes and map them into I mean into an object, like I mean similar to hash map. So how we map them, so we can transform them into the number of occurrences or number of the frequency, and then pass it to reducer.
Okay. And I still don't understand how. Let's suppose this is a Donald, again using the same, abusing the Donald name. But let's suppose this is a term.
Yeah.
What would be the mapper step over here? What operation am I doing here?
Yeah, I mean, so I think here it is not possible. Why? Because we'll have multiple objects. So, so the map step is applied only. I mean, the transformation can only be applied on one particular object. Like we cannot combine with other. I, I
Mhm.
mean, I'm assuming. So that's what I.
Yeah.
Yeah. No, I think
So
that's not a good
uh,
solution.
I'll take options that people are typing in the comments as well. So Jalkrit is saying, Jackrit, sorry, is saying that we can use a NoSQL DB as well. So any time you appear for a system design interview, you should refrain from saying terms like NoSQL. I'll use a NoSQL DB, and that will solve the problem for you. Why? See, Google search type head problem can be solved using Elasticsearch, right? It gives everything that I want out of the box. The aim for a system design interview is to judge whether if I give you a new problem, can you design it on your own? And then if you answer if your answer to a particular question is that I'll use a NoSQL DB, my question would be which DB would you use, and then I'll dissect whether you know the architecture, how that particular DB is designed or not. So unless you don't know how the architecture, how the DB is architected, do not use these terms in the interview. These are a red flag when you use a random technology and uh, don't know what is the architectural decisions behind that particular technology. Try to stick to the basics. If you're using caching, don't say Redis. Say I'll use a cache. Uh, and when you're saying you use the cache, it should be clear in your mind that hey, this is going to be my key. This is going to be my value, and my retrieve. This is going to be my retrieval pattern, right? That is very much essential during an interview. So keep that in mind. Yeah. Sorry. Over to you.
Yeah, I mean, so yeah, I cannot think of it.
Anyone who's done machine learning, they would,
Okay.
I think, be able to uh, get a better hang of it. It's a simple statistical tool, typically used in uh, not just machine learning. Machine learning is one area, but it's a purely statistical way of doing things.
So
So
someone said
Arpit says
Bayesian recharge.
Bayesian. Okay, Bayesian, not really. Uh, but what you can typically do is use sampling.
Okay.
The idea of sampling is that if it is popular, no, don't use average or anything like that. Just use sampling. If it is popular, right, there most of the chances, if you just skip 99 requests and choose the 100th request, it will be the request of the most popular one. For example, if it's a India versus New Zealand final that is going on right now, if I search for IND and missed out, just randomly choose the 100th request, it will be for India versus New Zealand. And because I have that kind of scale, I can just remove or let go of the 99% of my request and just choose one request that is coming to me. Of course, there will be some error threshold over here. It will not be accurate, but it will be a very much close to accurate guess, I would say. So sampling is one more thing that you can typically do. I'll only consider the 99th or maybe the 100th request. 99 request, I'll just I won't just care about it. And in fact, this sampling way is used in many applications, right? What I was saying is, so I'll just summarize what I just said, right? What I just said was that if something is very popular, like for example, if I type IND, IA will automatically be suggested because India has been searched by many people, right? If it is, if there is something else that is coming out of IND as a prefix, it will be searched by many other people as well. And by the law of averages or by the law of randomness, what I can surely say is that even if I remove the 99 first 99 request, whatever is the 100th request, that will the probability of getting that particular number which is popular, that is really high for a actually popular request. I'll give you a small example. I'll write a let's suppose I have four spaces, 1, 2, 3, and 4. All right. What is the probability of picking one? It's 1 by 4, 25. And so is
Yeah.
the case with every other number that is there in the array. Now let's make some more interesting. Now what I've done is I've added one more one. Now if I ask you to pick a number randomly, there are 50% chances that I'll end up choosing one. Now let's do remove one, add one more one in the four numbers. The percentage now shoots to 75% chances of getting one, right? And this is the law of popularity. Out of the four numbers that I had, one is really popular because it is occurring 3 times. If I choose a number randomly out of this particular batch, I have 75% chances that I'll get one. For truly popular systems, the occurrence of this one is over 99%, right? And that is what I was hinting at. You just sample your request, create a sample of, let's say, 100 batch. Out of that batch, pick one element randomly, and the chances are that you will end up picking up the most frequent or most frequently searched phrase. So this is a small idea about sampling that you can go back and apply in other systems as well. Yeah, I hope this leaves you with a food for thought. And yeah, cool. Anything else that you want to add, Lokesh, on the problem that we have discussed?
So on backend, yeah, I think that's it. So I mean, just one thing is that maybe on clients we need to add throttling that so like as we are typing, so like we said debouncing. So this term called debouncing. So I mean that means, let's say if I type a and there's an interval like like some 600 milliseconds like that. So if I stop typing, then I should send a request. If I'm not stop typing, so I should not send the request. So that debouncing maybe we'll add on clients. So
Right.
to optimize, yeah, I think that's
Right.
it from my side.
I think your voice is cracking. I don't know if it
Oh,
is, if that's just me, or
oh.
is it cracking
Is it
for everyone.
is it
It's
fine now?
better now.
Is it fine?
Yes,
I
yes,
mean, some
yes,
maybe.
yes, that's better.
Yeah.
All right. Cool. So we've discussed a problem, a system design problem with everyone, right? I think we are quite done with the 1 hour mark that are typically, added, given for a system design interview as well. I'll give you, before leaving, I'll give you guys a thought about uh, what are the typical challenges that people face during system design interviews, right? Pacing yourself is quite important, right? I think the pace that you showed, Lokesh, was spot on. We were able to cover quite a lot of ground in 45 minutes. We didn't touch upon many factors as well. I didn't go deep into understanding the how would you implement a try and all that, but I think that is not an objective of a
Yeah.
uh, objective as well, right? We didn't go into things like rate limiting and things like how would you actually persist a try on DB, right? Everything
Yeah.
was there in memory, so we didn't go into how would you persist a particular try, so that
Yeah.
in case the server restarts, how would you handle that? We've not discussed uh, so we've not discussed the length of a particular prefix that you will add. So would you add a also as a prefix into the consistent hashing ring, or would you require a minimum length? If you're having a
Yeah.
minimum, like what are the pros and cons of all those things? That is something that we've not discussed. But I think within a given the time frame, this is a decent enough discussion. There are multiple other aspects as well that we can look at. For example, personalization. Typically, if you are interviewing for a senior role, you would be asked to go into one peripheral area. I didn't get a time to dig deeper into the other peripheral features that we had missed out. The
Mhm.
other peripheral features are primarily there to test whether your approach or the solution that you're giving is extensible or not, right? For example,
Okay.
if on this particular system also you want to add personalization, how would you change or tweak your
Yeah.
system? Do you
Yeah.
require to change the entire logic? If that is the case, then your system is not extensible. And extensibility is a major component when it comes to testing out things, right? So I'll probably jump to questions that are there in the comments, right? If you have other prior engagements, I think I had blocked only 1 hour of your time, Lokesh. If you have any prior other engagements, feel free to drop off. I'll take the questions and then I'll wind up. Do you want to stay or
Sure.
do
Sure.
you want to?
So I want to drop off because my mom is waiting for dinner. So yeah,
Sure,
I'll
sure.
drop off, guys.
All right. Thank you so
Okay,
much
guys.
for your
Thanks.
time, Lokesh. Have a nice day. Bye bye.
Yeah. Thanks. Yeah. Bye, guys. Thanks.
All right, guys. So I'll take up all the questions that might be there in this particular chat window. Uh, if you've still not typed your question, please do so. If you want me to interview you on do a mock interview for you as well, please mail us your resume at youtube@scalar.com. I'll just type it down so that it's uh, visible for everyone. This is the ID that you should typically be looking at. All right. Let's now go to the questions. Bhagya says fast response. Okay, these are the answers. Where are they in question? Should we handle location, current issues, and frequency, at least in count? What's the profile of the interviewee? I think Jai Kirat, we told like in the beginning we started off with the profile of the candidate. He was having 6 years of experience, an SD2 at Akamai, and prior to this he was working with Book My Show. I hope this answers your question. Uh, so Jayant has a question. In yesterday's short URL, why we use user ID for the table if you're searching for short code in the whole DB and providing the actual URL won't be time consuming. How about using a key value pair? Just one that was so the schema that I wrote that was primarily for a system with a very less amount of uh, uh, which is basically designed for very less users, not for a massive scale. A KV, a minimalistic KV is the one that will work the best for a URL shortener kind of a design. So try can be partitioned based on location. That is not a good approach, I would say, Arpit. The reason being, because if you break down the try on a location basis, that will be adding personalization. But what we were designing today was basically a search type head that is globally accessed, and the frequencies were also changing globally. The prefix approach that we discussed at the end is basically the correct approach. Arpit says you should not block reads. How does it matter if the value goes a little here and there? Exactly. I think what he's referring to is that when we are writing a particular system, that is when we should never, whenever we update a particular frequency of a particular record, that is when we have to basically block all the reads because the write will take a lock on the particular record, and hence reads will not happen. So we should avoid it at all cost. We have discussed two approaches to avoid that. One is hashing and the other one is sampling. So we can use either of the two approaches to uh, to basically block down the reads and write value. So I see there are many people who have told that caching is the best way to do this particular thing. However, I would like to differ from them. Caching for a search type ahead is not a very good idea, right? We are actually caching quite a lot of things in the node where we just traverse to the node and we're finding the output. We need to understand that caching by itself is not a solution to reduce the latency. For example, if I maintain a hash map in memory, that is much more faster as compared to storing the data in Redis. So whenever you are appearing for interviews and giving your answers that I'll use caching, have instead of using caching word, or instead of using this, tell them where are you going to cache it. Are you going to have a distributed cache? Are you going to cache it on the client side? Or are you going to use maybe uh, or maybe at a load balancer, or maybe at a global cache or a DB cache? Specify what kind of caching you are going to do and what is going to be the key. Here in this case, I am not sure what can be the typical key for a particular cache. How many prefixes can you typically cache also, and the frequency also. What if, let's suppose I cache, I'm taking the same example, Donald. If I cache Don and save the top 5 words, how would you update the top 5 frequency? That will become a problem, right? So I hope everyone who's actually attending the session understand that caching here is not the best way to go ahead. So Vishnu says NoSQL is a good option. I think I have spent some time describing that. Don't directly jump to a NoSQL database. Identify what are the requirements that you would need to design such kind of a system, and then discuss the trade-offs. Directly jumping to a NoSQL is a red flag, especially if you are interviewing for a higher profile. For SD2, it will still be okay. But for SD3, it is a definite red flag. Is it's memory already in memory? What will you cache? What does it mean exactly, Arpit? That is what I was hinting at. What would be the criteria for caching? I think, Arpit, I've answered that. We will shard based on the prefixes. Okay. So Vineet is asking what we need to be prepared before giving an interview with you. In this particular mock interview, I had basically told Lokesh that, hey, I'll be asking you to design a Google search typepad. So the question was given to him already before he came for a mock interview. So whenever I take an mock interview with you, I'll probably give you a heads up that I'll be asking these questions. The sole purpose of giving the topic beforehand is we want to have a meaningful discussion while while on a mock session. In an actual interview, of course, you will not be knowing the topic, so it's important to understand the system design concepts and prepare based on that. So typically, if you want to do a mock interview with me, I can give you a topic and we can have a mock interview on that. Right? Any such stream for low level design? So this system design interview is a superset of the low level design, right? It's based on two important uh, parallels. One is the low level design. For a system design interview, you need to design the schema. Schema designing comes under a part of low level design. I, as an interviewer, might ask you to write some classes and code for that particular uh, business logic that I'm asking you to implement. If you are a more experienced candidate, I might spend more time in discussing about the systems. Right? If you have lesser experience, I might ask you to design the classes. For example, the same question: how would you go about designing chess? Uh, I would ask this question differently to a person who's has maybe a college fresher or maybe have 2 years experience, and maybe with a person of 10 years experience. For a person with a 10 years of experience, I will drill deep into how would ensure make this particular chess game into a multiplayer game, or maybe not a multiplayer game, basically a two-player game, two-player online game. How would he bake in artificial intelligence? How would he make sure that there is no there's no cheating component that is happening in the chess tournament? So, uh, doing uh, focusing more on the system design aspects of it for a 10 years experience. For a lesser experience, I'll probably spend time in how would you design the queen class, how would you design the pawn class, how would one extend to the other, and how would you abstract out the common functionalities. That is what I'll test probably for a with a 2 year experience candidate. I've learned from thank you so much. I hope I take it as a compliment. uh, in memory, hash map is not scalable, can be used by a distributed server. So you can have a Redis cache as well, in case you want to have, in case you're limited by the number of, or limited by the memory that your application servers are having. You can typically take this component out in a different system itself, right? So that would not be a problem. Is it possible to explain try implementation at DB level in your upcoming YouTube masterclass? Uh, Unfortunately, YouTube masterclass will not use any concept of try. What we can, however, do is there are people like we also take masterclasses on data structures. We can pick this topic up in one of the data structure masterclasses, not at a system design masterclass, right? And DBs, as far as I know, there are no DBs which will allow you to persist or try. Uh, right? You have to store it as an object and retrieve that as an object. For R much greater than W, keep cache on servers and have some hybrid approach for write through and write back policies to update the data back. Yes, Pratik, we can do that, but understand that tries are also stored in memory. So by storing by having a separate cache layer, you are not actually gaining anything out of it. The amount of time you will spend on reading from a try will be closely similar to what you will to the performance that you'll get out of the cache as well, because essentially both of the systems are reading data from memory to find out the top key elements for a particular prefix. The max you have to go for is maybe 3 or 4 characters, or maybe 5 characters max, and you'll get the complete string. So you are actually not going traversing a lot of data when it comes to having the reading it from the try. Redis is a event driven system and not necessarily slow need. Okay, it's he's answering this Anand. What is the question of Anand? Okay, Redis is single threaded in nature. It can slow down the entire system. Uh, so Redis, even though it is a single threaded, it can serve the kind of latencies that you can get out of Redis server is around 1 to 2 or maybe sub 5 millisecond kind of latencies. So in 1 second, you can typically serve from a single thread itself. You can serve around 500, 200 seconds, and then there will be thread multiplexing can also happen. So sorry, you can have a multi-threaded application interacting with this particular thread. So that also will gain give your system a huge boost. So uh, using context switching and all that, I have had instances where I can, with a single Redis server, I can serve million QPS. So Redis is blazingly fast, even though it is a single threaded application. Redis is an event driven system and not necessarily slow Node.js, but very fast. CPU intensive. So Arpit says Redis is event driven system and not necessarily slow. Is drawing parallelism from a Node.js server. CPU intensive application do require multiple threaded system, but not which are just network IO intensive. Agreed on this. Most of the time is spent on IO thread. So exactly. So thread content, not thread contention. I forgot the term for that. Yeah, context switching. So context switching will there'll be multiple threads which will be reading the data, and using threads will switch the context to give chances to other thread which is waiting for the waiting to be get into running state. Sharding, please. I think Bhavan, what you're asking is, are you asking me to explain what sharding means? I'll be uploading one video on sharding on under the system design series. So please stay tuned. Right. So uh, if you're interested in knowing any other system design concept or topic, please feel free to comment on this video. I'll end this video now. But tomorrow, I'm going to tell you about how to answer the coding experiences. Like how do I answer coding questions, DSA questions in an interview. I'll probably invite one more speaker who will tell. So uh, I'll basically invite one more speaker who is also done multiple, taken multiple coding interviews, have himself cleared multiple company coding interviews at multiple different companies, at farm companies as well. So tomorrow will primarily be focused upon how do you appear for and how do you think about a approach when you're going for these coding interviews. And day after tomorrow, I'll take one mock coding interview, similar to in a similar format that we have done today, right? So I'll see you guys tomorrow. I'll leave leave the class now. Hopefully that made sense for you. Please subscribe if you have not subscribed to our channel. Right? I'll see you guys tomorrow.